An exponential function is of the form a to the x for a positive number a. For example, f of x equals 2 to the x is an exponential function. How is this different from something like x squared? It looks similar, but it turns out to be very different. X squared has a variable raised to a power. In exponential functions, the variable is the power. The variable is in the exponent. Let's make a table of values of 2 to the x and see what the graph looks like. So we have y equals 2 to the x. Let's take x equals negative 2, negative 1, 0, 1, and 2. So this will be 2 to the x, so 2 to the negative 2. I'll have to remind myself how negative exponents work. That's just 1 over 2 to the positive 2, so it's 1 over 4. 2 to the negative 1 is 1 over 2. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. If I plot these points, so let's plot these points. So x equals negative 2, y equals a quarter, negative 1 a half, 0, 1, 1, 2, 2, 4. I get this graph that starts very small and then after 0 gets big really quickly. Why is that happening? Notice a few things here. First of all, if I take really big negative numbers, like if I take 2 to the negative 8, do I get negative numbers? No, not for y. I get 1 over 2 to the 8, which is still a positive number. It's a really, really small number, but it's positive. I also can't get 0. I can't take 2 to the something and get 0. So notice here that the y values get really, really small, get really, really close to y equals 0, but they never touch y equals 0 and they never become negative. On the positive side, when you take x to be bigger and bigger in the positive direction, the y values get big really, really quickly. They grow exponentially. That's a characteristic of exponential functions. If we had the graph 3 to the x instead, we'd have a very similar looking curve. It would just have the points over here be a little bigger. So if we had y equals 3 to the x, then when x equals 1, you'd get 3. And y equals 2, you'd get 9. So it'd be bigger over here. But then for negative x values, and you might want to plot some of these yourself to confirm, you'd actually get lower, like you'd get a third and a ninth. Oops. So we get this. So this would be y equals 3 to the x. All exponential functions look more or less like this, just maybe steeper or less steep. Notice in particular that every exponential function goes through the point 0, 1, because a to the 0 is always equal to 1, so you always get 0, 1. If a, the base, is bigger than 1, then the graph will look like this. If the base is less than 1 but still positive, like for example a half, you get something similar but slightly different. And you can try that on your own to see what happens to the graph when a is less than 1. Now, you may have heard of a number called e in high school. E is an irrational constant like pi. Irrational meaning it has a decimal expansion that goes on forever and doesn't repeat. Constant, as opposed to a variable, which can be any value we want, this is a constant number. It is always the same number. It is always 2.7 and so on. We can take e, this number, which is approximately 2.7, and create the exponential function with base e. We could make e to the x. Since e is between 2 and 3, right, 2 and 3 surround 2.7, then the graph of e to the x is going to be somewhere in between the graphs of 2 to the x and 3 to the x. So the graph of e to the x is going to look something like this. It's going to hit 2.7 there when x equals 1, and I'm going to go like that. So that's the graph of e to the x. Where does this number come from for e? Why do we care about 2.718, blah, 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 blah? Well, it actually comes from these graphs and the tangent lines at x equals 0. So each of these graphs we could draw a tangent line. We can draw the tangent to 2 to the x. I could draw the tangent to 3 to the x. It's going to be a little bit steeper. I could draw the tangent at e to the x at x equals 1, and it's going to be somewhere in between those other two tangents. And if I drew this really accurately, the tangent to e to the x actually has slope 1. And that's where the number e comes from. It's chosen specifically to be the base of the exponential function that will make a curve with slope 1 at the point 0, 1. That's all e to the x is. It's a specific exponential function. It's just an exponential function with base e, which is about 2.7. There's a button on your calculator for e to the x. Here it is right here. On this calculator, you'd have to press Shift and then the ln button to get e to the x. And so you can use that to calculate the decimal approximation of things like e to the 5. You are expected to know the approximate value of the number e, so 2.7, what the graph of e to the x, and indeed all other exponentials, looks like, and how to evaluate e to the x on your calculator. Those